Hello everyone, welcome back to this Beckhoff TwinCAT 3 motion control step motor with the encoder closed loop numerical control series video. And in the previous two videos, I introduced the hardware wiring about this KL2541. This hardware wiring is the same idea as EL7040, the E-bus module, the E-bus step motor with the encoder terminals. Also, in the previous video, I compared the difference between the KL2541 and EL7041. The KL2541 and EL7041, they are almost the same. The only difference when we used in our actual project, the only difference will be the interface module. When we use the KL2541, the main interface module, we will use BK1120 that supply the K-bus. But the interface, this RG45 connector will run the EtherCAT field bus. Same idea, at the right side, when we use EL7040, this interface module will use EK1100, that is also an EtherCAT module. But this interface module supply the E-bus. Every terminal run as a EtherCAT node. Okay, in this video, we will shift to the software-wise. I will use my laptop run as the controller, and I will use the TwinCAT 3 software and connect my laptop to this interface module using one Ethernet cable. And then this interface module will connect with this KL2541 terminal. Other than this module, I also have a digital input, digital output, and analog module between this interface module and this KL. This demonstrates this is almost the same idea as your actual project. You definitely have some other signal modules, digital input, digital output, and other signal modules between this interface module and your KL2541, this terminal. Also, we will connect the motor and encoder according to this diagram. We will connect the encoder on the left side of this module, and the motor A1, A2, B1, B2 we will connect to the motor. And again, don't forget to supply the power to this module so that this terminal can supply the power to the motor. And this number 4 and number 8 at the right side slot here, we need to provide the power to this terminal. If a step motor that is a 24 volt step motor, you need to supply the power to here, 24 DC voltage power to here. And also don't forget to supply the power to the encoder. As I introduced from the previous video, some cases this terminal cannot supply the power. Depends on the left side module if it disconnected the power supply from the left side. If it does, so you need to specially supply the power to this encoder. Okay, this is the wiring. We quickly record that. And then let's shift to the TwinCAT 3 side, and let me show how can we use the scan function to scan this interface module. And our main target in this video, I will show how can we set up the parameter, the register parameter for this KL2541, this terminal. And I will show how can we set a certain value so this step motor can run as a 1 second, 1 revolution. We definitely need to calculate something here. That is very interesting. And also to verify my setting, I will use the scope meter connect to this pulse, this A1 here, and we can verify what the frequency from this output, this PTO high pulse output. Alright, let's shift to the TwinCAT 3 side, and let me show how can we scan this interface module so that my laptop can run this terminal module and we can control this step motor. Okay, if you quickly recall, from the previous series video, I used the TwinCAT 3 showed how can we program the NC function blocks like reset, power, home, jog, velocity control, and absolute positioning control. And at that time, I used the virtual access 3 to demonstrate how can we program and how can we practice this. If you haven't reviewed that series video, you can go to my channel. You go to my channel, Electrical Automation Hands-On, and then go to Playlist and find out Beckhoff TwinCAT controls or find out Motion Control. And then scroll down the playlist Beckhoff TwinCAT 3 control, this playlist, and find out MB10. So this is one series video, so I named the number here. So the first series video that starts from number 1. A number start from the MB01 motion control Beckhoff TwinCAT 3 NC series video. And the previous series video, we have 10 videos there. So if you have time, highly recommend you can review from MB01 to MB07. And this series video talking about Beckhoff stepper motor control, we start from MB08. Alright, let's go to the software side. I will use this project as my base. It's still okay if you start from the scratch. You can create a new project because we are going to talk about the I/O portion. So the existing function block, we will not use that in this video. It's still okay you start from the new project. So I will minimize them here. So in this video, we will mainly talk about the I/O portion here, and I will show how can we scan the interface module. And now I will power up the interface module. I wired this station so we can see on the left side that is the encoder, on the right side that is the step motor. And here I jumped one wire here so that I can use the scope meter to measure the high pulse. And now I connect this Ethernet cable and the other end that connect to my laptop. And now I will power up this station. Power up the station. Okay, by default, all those indicators are off. So now let's shift to the software side. You can also start from the scratch and you can create a new project. After you open TwinCAT 3 software, go New Project, create a new project, select TwinCAT 3 project, and then select the directory. Alright, create a new project. And then you can create a PLC project, add a new item, create a PLC project. Click this standard PLC project and create a new PLC project. Okay, we temporarily create this PLC project, but actually we will not use that now. We will go to the I/O directly because the basic idea from Beckhoff, their program in the PLC project and their I/O can be totally separated. So to scan the I/O, we can directly use this I/O scan hardware. And this is the program portion and this is the hardware portion. We can directly go to I/O here and add this devices, right click, click this scan. And now I'm using the Ethernet cable connecting that BK1120. Click this scan. Okay. Okay, it found this EtherCAT. Okay, click OK. Scan for boxes, yes. And now I'm using my laptop running as a controller and use the TwinCAT 3 software scan all the devices using this EtherCAT, this field bus. And we can shift to active FreeRun mode. Okay, that's very important. If you click the no accidentally, it's still okay. If you forget this FreeRun mode, you can click this button toggle FreeRun state. When we are running the pure hardware, basically we will use this FreeRun mode. FreeRun mode means we will directly manipulate all the terminals at here. So if we expand here, boxes 1, BK1120, that's my interface module. And our KL2541 is at here. It has one channel here, and we can double click, we can look at the status. We can also look at the online value from the status here. If we try to control these devices, we can directly write the control and directly write the velocity value at here. Okay, this is the FreeRun mode, so we can see this value is online. We are monitoring the actual value at here because we are at the FreeRun mode. We can directly write the value, directly control this terminal. Alright, after we scanned and after we find out this KL2541, this terminal through this BK1120, well, the EtherCAT, this field bus. So now we can set up the parameter, set up the register value inside the KL2541. To set up the register parameter, we better review the manual of this 2541 module first. So you can download the manual, go to the documentation and download. I'm opening this KL2541, this manual. Because of this module, that is the KBus module, to set up the register value for this module, this terminal, we will go to the register description here. And from this menu, we will see one configuration software, that is a software KS2000. Actually, this software is a very old style from TwinCAT 2 that age. But currently, we are using TwinCAT 3 software. The TwinCAT 3 already built in the tools that we can set the parameter for this register value of this KL2541. Quickly go through the parameters we need to double check or need to set. Okay, so we can go to the register page 0. So we start from the R32. But actually, we can use most of them as a default, especially when we are using the Beckhoff motor. If you are using the third end motor, probably you need to go through some details to check out if some parameters does not match with your hardware, with your motor. Okay, for example, in my case, I'm using AX1060 that step motor, and that step motor has a 200 lines per revolution. That means to run one revolution, to run one circle, this terminal need to send out 200 pulses to this step motor. Here, that is a full motor steps that represent how many pulses per revolution. By default, that is 200. That is the same with my step motor. But if you are using another step motor, probably you need to change this parameter here. And R34, that is the encoder incrementals. We will introduce this in the next video. And some current setting, we better double check. For example, 35 and 36, that is the maximum coil current. And the maximum velocity as well as the coil current. Okay, this is percent. So we can set the limitation for the current delivered. Okay, another key value we need to scroll down. Find out this R46, that is step size. Usually we call that micro steps. That means per step we divide it to some micro steps so we can fine control the steppers. So the higher value we set here, the smoother stepper motor can run. However, the higher value we set here, the high speed will drop down because the entire high frequency from this module, that is 125 kHz. That means the higher value, the microstep value we set here, the shorter the counters of the pulses delivered from this terminal per second, that will drop down, right? Because the total volume that is there. So if we set up higher this ratio, the counters, the pulses numbers delivered from this terminal per second, that will drop down. Which means the higher value, the microstep we set here, the highest speed this terminal can control the motor will drop down. So we need to trade off the step motor running smoothly and trade off the highest speed this motor can run. This terminal can control the step motor. We need to keep this balance. So next question, how can we set up the parameter using the TwinCAT 3 software? Okay, let's go to the TwinCAT 3 software. After we scanned this station, we can see this is the interface module, EtherCAT interface module. And from here, we can right click. We can see it shows one selection here, register access. Click. And keep in mind, we are under the config mode. And from this job list, let's select the terminal we're going to set. Okay, this is terminal 6, KL2541. And this module has only one channel here. And from this register list, this number, that is a R number. For example, the first value we need to double check, that is R33. That is the lines, steps per revolution. And by default, that is 200, which is correct. Okay. And we can check out other current values, the R35 and R36. That is the coil current A and B, the percentage value. By default, that is 100%. If we are going to change the value, for example, if I'm going to change the R35 from 100 to 95, I can type in the value and then click the write. So we can write this register value to the terminal. Okay? And now let's review this R46, this step size. The value that shows 6, that means 2 power 6, that is a 46 value. If we set 2 here, that means the micro step we will set, that is a 4, because 2 power 2, that is 4. If we set 3 here, that is a 2 power 3, that is a number 8. Okay, by default, we will allow this motor run smoothly. So we will set 6. That means the value we will set, that is a 64. Okay, if you find your terminal cannot run that motor higher anymore, so probably you need to drop down this, drop to 5 or drop to 4. But you will find your motor will not run that smooth enough. So from this list, we can write or read the register value for the terminal. Okay, so we do not need a specific tool. We just use from this interface here and right click this register access. Okay, this is a parameter setting. And then let's shift to the terminal here. And keep in mind, we are under the free run mode. And then click this terminal number. And from this right list here, we can see the actual status now. So this 3 status position and external status, that shows the current status from this terminal. And if we are going to control this step motor, so we can use control, velocity, and external control, these 3 values here. And because of we are under the free run mode, once we set some value to this velocity, and once we active this control, actually we can deliver the high pulse to the terminal, and terminal can control the step motor go on and to run. So firstly, let me demonstrate this. Okay, so now let's click this velocity from this list here. It will jump to the velocity setting and the link. And then let's go to online. So currently it's showing the online value. Now it's a 0. Okay, if now I type in, let's temporarily set a value. For example, if I click this write and type in the 2000 value, the highest value we can type in here, that is a 32,767 value here. That is decimal value. And now let me type in a small value, 2000, and click OK. So we write this 2000 decimal value here. And it's not enough. Now we set 1 pulses value here, and let's go to the control. Control, that is the digital value, 0 or 1. So we can turn this on. I can set 1 here and click OK. So once I type in 1, now the terminal is delivering this 2000 per second. So now from this terminal, it's delivering the 2000 per second pulses here. And in the meantime, we can see this run indicator now that is a solid on. And this IO run that shows high pulse flickering there. And now I'm using this probe connecting to this output A1, this terminal, and try to measure what the pulses, what the frequency pulses delivering from this terminal. Okay, it's measuring this high pulses here. So if I'm going to use this score meter, this is a Fluke 97. And if I click this function and go to select the frequency, currently I just give an arbitrary value 2000 from this terminal. And if now I'm going to set a certain value, allow this motor run as 1 second per revolution. And let's see how can we calculate this decimal value and how can we set this decimal value. Okay. To deeper understand this calculation, we better open the KL2541 manual. And from the chapter 2.6, the KL2541 technical data, we can see the maximum step frequency delivered from this terminal, that is 125 kHz. And under this 125 kHz, that integer value, that decimal value we can set, that is a 32767. Also keep in mind one thing, that is a step pattern. So currently the step pattern we are setting the 64. So under the 64 step pattern and with maximum step frequency 125K, we can set the 32767. So we can calculate if per second we run one revolution. To calculate this pulses setting value, to calculate this, we can use this equation. So we want to get what the decimal value we can set to this terminal. So that time we want to run 200 pulses per second. That is one revolution. And per step, we have a 64 step pattern there. We also call this step pattern as micro steps. And right side, that is the maximum value when we set the 72767 this value. So this module can deliver 125 kHz. So through this equation, we can calculate what the decimal value we can set to this terminal. Through this equation, we can calculate the decimal value we can set, that is a 3355. With this setting value, the step motor we can run one revolution per second, and the actual pulses delivered from this terminal, that is a 12.8 kHz. So we can verify that. Now I can set this 3355, set this value to this terminal, and let's verify the high pulses delivered from this terminal. And now let's shift to here and go to the velocity. And before that is 2000. Now we are going to change to 3355. And now let's write 1. Okay, so we can see the speed is higher than before, because before that is 2000. Now we are running 3355. And if you count the time, we can see now the motor is running one revolution. If you count the time, we can see now the step motor is running as one revolution per second. And in the meantime, we can see the pulses from this module. Now it's running one revolution per second. And now from the scope meter, we can click this hole and we can see the frequencies measuring. It shows 25 or 26 kHz. It should be the 12.8 kHz. But what the reason why is showing the 26 shows double times of this calculate this value. Personally, I think the reason why, if we go to the motor, this menu, we can see for each pulses from the step motor, it also needs two groups here to allow the step motor start to run. It has a two group poles inside. That's why to allow the step motor run as the one revolution per second, so the measurement high pulses that shows double. This is what I'm thinking. Okay, going back to this calculation. So this is the key things in this video I would like to show, because some cases you may not using the encoder. You just need to open loop control the step motor. If you have to program by yourself to open loop control the stepper, and you have to generate the PTO, the high pulses to the step motor, and program the counter to count how many pulses you delivered to control the distance travel, rather than using the numerical control, then this equation is very important. From this equation calculation, we can roughly calculate to run a certain speed what the decimal value we need to set at the velocity setting at this terminal value. But fortunately, in this series video, we will use the NC, the access control. When we use the access control, we do not need to calculate this. That's the beauty of using access control. The only things we need to do, that is the configuration. But the reason why I discuss this now, that's because we can set directly to the terminal and we can start the motor to verify the motor. As we can see, we haven't set up any program and haven't set up any configuration yet. Our controller now is under the config mode. We are just under the free run mode. So from this module, without any program, we can set a certain velocity value here and turn on this control bit so we can fire the motor. Especially we can run a very slow speed. That time we can test the mechanical system, we can test the direction, we can test some connection, mechanical connection, something like that. So we can quickly verify if this motor can get the correct power and can drive the mechanical system. That allows this system directly controlled by this terminal. And we can directly control the motor without any program. Alright, that is this video. In this video, the key operation we did, that is under this devices, we click the scan the EtherCAT module. And using our laptop, we run the free run mode. And then we set a certain value to this velocity here, directly control the module. Also, I showed how can we write the register value to this terminal. Go to the BK1120, this interface module, right click, click this register access. Alright, using this way, we can directly control the step motor and we can verify if our communication is working properly, if our wiring connection is working properly. Also, we can further verify if our motor can be powered correctly and the mechanical can be connected correctly. And in next video, I will show how can we verify the encoder. I will use the scope meter to measure the encoder value. Okay, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.